All right, guys, so we are learning lesson 10.3 today. Watch the video, take notes. Mr. Chai and I are on the Schoology conference. If you have any questions, tomorrow we have office hours, so please email Mr. Chai or myself if you would like to meet with us or have any questions about any of the lessons that we've learned in this chapter and want to review. We will have a review day on Monday where we go through a bunch of review problems that will help prepare you for the test. And then your test is on Wednesday over chapters 9 or lessons 9.1, 9.2, 9.3, that extra graphing lesson, and then 10.1, 10.2, 10.3. Okay, so watch the video, take notes, do the homework check. Let's go ahead and get started. All right, so lesson 10.3 starts on page 471, and today is the 7th. Actually, it's not April, it's May 7th, 5-7. So we were talking about shapes of distributions. So looking at like histograms and dot plots and looking at how data is distributed, how it's kind of shared or represented. So one term that you're going to need to know for today's lesson is skewed. And what skewed means is that it has a slanted direction or position, skewed. You can use dot plots and histograms to identify shapes of distributions. So if you need to write that down in your notes, you can always pause the video if I go too quickly and, so you have time to write that down. All right, so we're going to look at a couple things in your textbook. It's easier to look at the examples on the book than me trying to recreate the graphs. So we'll look at the key ideas on page 472, example 1, example 2, and number 5. So I'll show you on the textbook. All right, so here's key ideas talking about symmetric and skewed distributions. So if a graph, this is a histogram, you can tell because the bars are touching. So if the bars look like this, they're kind of increasing up this way and drop off, that means it's skewed left. So the tail, if you follow where the tail is pointing, the tail is pointing to the left, so it's skewed left. The tail of the graph extends to the left. Most of the data is on the right side of the graph, so the tail, it's skewed to the left. If it was a slide, you would be sliding to the left. This is also called a negatively skewed. It's negatively skewed when it looks like this. You can think that because the slide is going towards the negative numbers on a number line. Okay, this is symmetric. When it's pretty even on both sides, symmetric, the left side of the graph is a mirror image of the right side of the graph. That's when it's symmetric. Skewed right is when the tail of the graph extends to the right. Most of the data is on the left, and it's also called positively skewed. So think of it as a slide. You come up to the graph, and you're sliding to the right. So this is skewed right. Slide right, skewed right. Trying to help you think of different ways. Positively skewed, the slide is going to the positive side. Does every single graph, do all graphs fall into one of these three categories? No, we've done tons of graphs that are neither skewed left, symmetric, or skewed right. There are many different types of distributions. These are just three that we're going to look at today. If all the dots of a dot plot or bars of a histogram are about the same height, then the distribution is a flat or uniform distribution. A uniform distribution is also symmetric. So if it's all the same, it's called flat or uniform. All right, let's look at this example here about passes thrown and daily snowfall amounts. So describe the shape of each distribution. If this was a slide, you're sliding to the right, so that means it's skewed right. Okay, you're sliding towards the right, and it's positively skewed. Most of the data are on the left, and the tail extends to the right. So the distribution is skewed right. Okay, looking at this one, passes thrown, frequency, number of passes, there are intervals, so this is a histogram. You can see here, the left side of the graph is about a mirror image of the right. I mean, it's not a perfectly symmetric, but it's pretty close, right? Little, bigger, 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 and then the biggest one in the middle. So the distribution would be symmetric here. All right, you all try this. Try to describe the shape of this data. Pause and get your answer. This would be skewed left, because if it was a slide, you would be sliding to the left. So skewed left is correct. All right, so this example says the frequency table shows, here's your frequency table, the ages of people watching a comedy in a theater. Display the data in a histogram, then describe the shape of the distribution. You can't quite tell the shape of the distribution here. This is your frequency table, so we are going to make a histogram. Now the book did it for us, so we're going to use this example, and then we're actually going to make our own down here. Okay, so draw and label the axes. We have frequency, and then we have ages. I need to go all the way up to 20, so they counted by 4s. And then our intervals 10 to 13, 14 to 17, etc., all the way to 34 to 37. Notice how they're equal intervals as well. They're the same size. The bars are touching. Now, once you plot into your histogram, you will see that most of the data is on the right. If you were doing this as a slide, you would slide down this way. Okay, so this is skewed left. You're sliding left. Most of the data is on the right side of the graph. So now a frequency table down here, we're going to do try it, and you are going to try it. The frequency table shows the ages of people watching a historical movie in a theater. Display the data in a histogram and describe the shape of the distribution. So go ahead and pause so you have this table, make your histogram, and then say what the distribution is, skewed left, right, or symmetrical. Okay, so here we're on try it number 2, page 473. I set up my axes. I have ages, the frequency. I needed to go up to 40, so I decided to count by 5s, 5, 10, 15, 20, all the way up to actually 45. Title, people watching a historical movie. Now I need to put my intervals, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 to 69. Okay, now I need to graph my data. So go up to 3, 18, 16, 17, 18, go up to 36, a little bit past 35. Go up to 40. Go up to 14. And then go up to 5. All right. So, what would you say about this graph? Kind of hard to determine, right? Here's the middle. Could go this way, this way. These two aren't too far off, so that's not too big of a difference. These two are kind of equal. These two are kind of equal. So I would say symmetric. Symmetric. If you said skewed, like you could slide this way, you're saying then that most of the data is to the right. If you said skewed left, then most of the data is to the right. That's not necessarily true over here though. These are two low points to the right. So this one was challenging to see, but if you look and say these two are similar, these two are similar, these two are similar, it is symmetric. If it's hard to determine whether you're going to slide this way or this way, then it is symmetric. I feel like it will be pretty obvious for you if it's skewed left or skewed right. If it's hard to determine which way it is skewed because they're pretty even, then it is symmetric. So go with that. Okay, next let's do this one. Which one doesn't belong? Which histogram does not belong with the other three, and explain your reasoning. Looking at this one here, this one, and this one. Which one does not belong? Okay, you should say this one does not belong, and why? These are all symmetrical. This one is almost even uniform or flat, or symmetrical. This one, it slides to the right, so it is skewed right. Most of the data is to the left. So this one is skewed right. The others, histograms, are close to symmetric. Okay guys, so that was a short lesson. Make sure you took your notes because those notes will be helpful on the homework check and on the test as well to help you keep track of what's skewed right, skewed left, symmetric. Not all data fits into those 3 types of distributions. There's lots of data that do not fit into those types of distributions. So sometimes it is hard to tell. We'll make sure to make it pretty obvious when we're asking you which type of distribution it is so you won't be too confused. All right, Mr. Shine and I are on the Schoology Conference, ready to help you out if you have any questions, and please email us if you would like to meet during our office hours tomorrow. Thanks. Do the homework check. Bye.